Hello, everyone. My name is Gitika Gorthy, and today I'm very excited and honored to be interviewing a very special space champion, Miss Diane Malarik. Miss Malarik is the acting director for biological and physical sciences at NASA. She is responsible for providing strategic direction for the division and overseeing the planning and execution of its two-pronged mission of pioneering scientific discovery and enabling human spaceflight exploration. An incredibly exciting topic for me, and I'm sure everyone who's listening. Miss Malarik began her career in project management in 1992 at NASA Glenn Research Center, working on the material science space shuttle experiment, and has been managing programs and projects within the BPS division and its predecessor organizations intermittently over the past 30 years. Miss Malarik stated in a previous interview that she knew she wanted to become an engineer from a young age, and I'm curious to dive into her aerospace journey to see what led her into combining her passion for engineering and biology together. So, welcome, Miss Malarik. Thank you so much for taking your time to inspire the next generation of aerospace leaders.
Thank you. I'm pleased to be here.
Yeah, to just go on and kick off our conversation, I wanted to first start off by asking about your typical day. I know usually there isn't a typical day, but how do you generally like to structure your day?
Well, since I'm now the acting director of this division, my day gets structured for me by all the meetings that I have to attend. So, as one of the senior leaders within the Science Mission Directorate, we have a standing 8 a.m. meeting 3 days a week, so Tuesday, Wednesdays, and Thursdays, and we talk about things that affect all the divisions in our Science Mission Directorate. So the planetary division, Earth Science division, heliophysics, etc. And so that's how I usually start my day, is by starting with that meeting. But I have a team of about 10 civil servants that work for me, and they have very diverse backgrounds. And so we have staff meetings, and they are all leaders in their field. And so I have program scientists as well as program managers. And so our scientists work really more on the science and working out with the community, the research community at the universities. And then our program managers work with the budgets and the schedules and the implementation of those projects. So they work hand in hand together, kind of a scientists that are coming up with the ideas and the engineering that are implementing the ideas. So that team, it's a diverse team. Biological and physical sciences is very diverse. So we have, people that have, background in, doing biology with fruit flies and, plants. And then on the physical sciences, we have combustion and fluids and materials and fundamental physics. And so each of them has different areas of expertise, and they provide the leadership for each area. So we get together as a team to talk about what are the most important things we should be doing. As we come up with problems arise. How do we solve those problems? There are other groups within NASA, inside and outside NASA, that we interface with. So again, we're going to be talking about those things. So I'm at the NASA headquarters. And so we don't have any laboratories. We are an office building. And so all of our days that work at NASA headquarters are, we're spending our time with meetings, PowerPoints, spreadsheets, skills, policy documents, things like that. But I did spend 30 years at Glenn Research Center, NASA Glenn Research Center. I was more hands. So I was a project manager, and I would be in the lab with the project and the project team members, actually building up an experiment to go on space shuttle or space station. And over my career. So that's my typical day now, is spent in meetings and talking to others and collaborating. And as a division director, I'm, as I said, the hands-on work I've left behind, and I'm now setting process and policy and guidance and vision, for the whole organization.
Wow. Yeah, I think it's incredible that you were able to have that experience before the 30 years of working in a laboratory and translating that now to like a bigger picture, where as a leader, you're able to oversee all these different projects. And of course, even if it's filled with PowerPoints and meetings, I'm sure you have a very exciting time listening to the different project proposals and their updates in all of these different aspects of the biology and physical sciences division. So I can't imagine how exciting your job must be, even if you're not directly a part of those experiments and projects. And when you mentioned when you're talking, I could see that you were really passionate about the laboratory work that you have done and conducted at the Glenn Research Center. So I would love to learn more about it. What project were you a part of?
So my very first project was the isothermal dendritic growth experiment. So it's called IDGE. It was a shuttle experiment, and it was a materials experiment. And what we did is we flew on the space shuttle 3 different times, and we used a model material that was actually transparent, and we can watch the crystals form during solidification. So and to understand, so we can watch this solidification. You can get it in metals, transparent, and we also, there's a lot of the heat transfer is totally different in space. There's no hot air, hot fluid rises to the top, and in space that doesn't happen. And that creates convective currents and flows and in the liquid, and so that kind of perturbs the solidification. And what we were doing was, in order to better understand the underlying mechanisms, is we went to space so we can remove the gravitational effects, understand what is causing and how things solidify, but then back on Earth, you need to add back in those convective flows. So it's really about developing a really fundamental understanding of each of the aspects of processes that happen that happen on Earth, such as metal casting. And that project generated amazing data for over 3 flights on the space shuttle. And people are still publishing on that data that was collected in 1994. So there's hardware, there's some science, we had mechanical engineers, electrical engineers, software engineers, manufacturing technicians. Everybody has to pull together to build something that will gather the science data that we're looking for, and then integrating it onto into the space shuttle. And there's the operations, and so I've done that. That was my first project. And my last project, before I moved into program management, my last project was the scan test bed. And that was a technology demonstration. I went on space, the International Space Station. It sat outside the space station, and it had 3 different radios with 5 different antennas, new technologies for the purposes. That was a very challenging project. And I'm really proud to have. I started as a deputy project manager and finished out as the project manager. And the same was true of my very first project. I was the deputy project manager and finished out as the project manager. And so that's always fun. And that project team is really, people pull together. There's lots of challenges. I always say, General Motors or any car company, they produce 100,000 cars before they find a design flaw. NASA, we're doing one. We're only going to do one. And so there are lots of design challenges, and you find a problem, you have to come up with a solution, implement it, and move on. And so done before, and then do it in space. So that, adds a layer of complexity. So that was a great project. So it stayed up for about 6 years on space station, and launched in 2012. So it was a really exciting project. So, and then I moved into program management. So, and that is, a natural progression from, a field center such as NASA Glenn, and ultimately moving up to headquarters, which really helps me, bring that perspective of how it really works, boots on the ground, we say, at where the team is actually building things. So.
Okay, exactly. And I'm sure that provides you with really good insight when you look at these proposals and think about all the work that's being done behind the scenes. And just hearing you talk about those projects, I think it's incredible. I could see from your excitement with how you're talking about your experiments that you were really passionate and you are really passionate about the biological and physical experiments that are being sent to space. And when people think of NASA and space, they think of rockets and they think of blasting off into space, which is completely reasonable. But there's also this whole other side of the experiments that are being sent to the International Space Station, which is honestly revolutionizing the way we do a lot of medical biology related experiments. And so I'm curious to hear from your perspective, what excites you the most about biological experiments that are being conducted in space, and what benefit does it provide for humanity? Why should we care that NASA is doing all these really cool experiments in space?
We have humans up there, and we need to fully understand what does it mean, what will it be for the crew members. And not only that, as we move into this tourism, the area of space tourism, there are going to be lots of people. And right now our astronauts are super fit and super smart and super able and capable to go into these challenging environments. But as we expand space in we as a nation, we as in the earth that have tourists that go up there, that's not everybody's going to be super fit or and so this really expands the adventure of space to all. And so for us, we really need to understand, what does it mean, how is the body going to respond? And so our program uses model organisms to study how biology reacts in space. There are a very limited number of crew members. And so, as you know, in experimentation, especially with biology, you want to have lots and lots of samples to look for trends. Individuals respond in different ways. And so for us to be able to use different animal models where we have lots of them, for example, fruit flies, we can get a lot of fruit flies in a very small area, but their hearts are similar enough to humans for us to really derive some understanding of what's happening. So that's really exciting. And then also the idea eventually, and this is personalized medicine, that is the wave of the future. And NASA, we need that, because we're sending just a few people at a time. And if we could really understand how this person's going to respond, a particular person is going to respond to either the radiation environment or the microgravity or low gravity or partial gravity on the moon and Mars. If we had better understanding, we could develop specific countermeasures, specific, say, drugs or exercise protocols, or whatever. Right now, it's not personalized. We have enough data. We say, okay, everybody has to exercise this amount. But wouldn't it be great if we knew, well, this person's genetics they're not going to be as predisposed, and so we can customize their countermeasures to them. And so that would be so applicable on Earth, as if we could have specific personalized medicine. So toward those ends, we have in development with the National Institute of Health and others a tissue chips initiative. So tissue chips are organs on a chip can humans than, say, a fruit fly, or other organisms, model organisms that we use. And so the tissue chip is another model organism, but is really revolutionizing medicine. And as you know, like even the drug companies are now moving toward tissue chips instead of testing in animals. Also, either not testing in animals at all, or going, or in conjunction using tissue chips to see how will the liver behave, how will, lung tissue behave. And so that is, pretty cool stuff. So what we want to do is ultimately have tissue chips that are representative and made from our space traveling crew, you know, like so that we could say, okay, this would be research for us to behave well, but eventually we want to use them for that personalized medicine aspect that they bring to it.
Yeah, and this topic is so incredibly exciting for me. I wish our internet was not this poor because I would be geeking out about how exciting this topic is. It's my personal favorite. I remember a few years ago in high school, my first internship was at NASA Ames, where I had a data set that I worked on a group on Drosophila and analyzing their cardiovascular system in
There you
space.
go.
And so it's like a perfect translation. And I was mind blown that a really tiny fruit fly could really tell us so much about a human's heart. And that was my first moment where I was like, this is so cool and so applicable to human health. And being able to use space to develop telemedicine to make healthcare more accessible for everyone here on Earth as well. And using space is kind of that place to innovate, create, and to bring that all back, bring that technology back down to Earth to help everyone is the key part of what NASA's mission is. And I think it's so exciting how NASA has all of these experiments. And so yeah, my next question for you is, as you were talking, I could really see the excitement you have for this topic. So what was your aha moment that inspired you to come into space and eventually combine it with biology? What was the aha moment? What was that journey like for you?
Yeah, so as you mentioned earlier, I always knew I was going to be an engineer from the age of 7. And I tell you, I really feel like I lucked into NASA and the space industry. I was never a big space aficionado, we'll say, but my university had a shadowing program, and they joined up with NASA. At the time, it was called NASA Lewis Research Center, and they chose 5 women engineers, freshmen and incoming freshmen, um, engineering students, and they paired us up and they had us shadow for a few days before our freshman year, the classes started. And that just really, turned me on to NASA and how cool it was. And so they had held summer internships for us. And so I worked there for 2 summers. On my 3rd summer, I knew that NASA was very cool. And so I came back when I graduated and have been working at NASA ever since. And so for me, I knew that NASA was really fun and vibrant and actually a big organization. And the beauty of being in a big organization is that you can move around quite a bit, and it feels like a whole new thing to you and a whole new job. And after I had been in research for 5 years in the polymer composites research, I moved into project management. And that's when I had my first project that I mentioned before. And so I think I was 27 years old and moved into project management. And I didn't know that project management was a career path at the time. That I didn't know that was a thing. And that was my aha moment for my career, was moving into project management. And I said, oh, I'm really good at this. I feel good leading a team. I feel good pulling people together, putting budgets and schedules, and solving problems. And one of the things to be a good project manager, I always say, is being able to make decisions with imperfect knowledge, and being okay with that and being comfortable with that. And so that played to my strengths. So moving into project management really put me on a career path for success. And so that's how I landed where I am now. And
Yeah, I think that I heard up till the end where it kind of got cut off, but I think it's really inspiring that you kind of were not afraid to change or kind of evolve into where you are right now with your career. You didn't stick like with one mindset entering college that this is what you were going to do, or entering NASA that this is the role I want to be. I think it's great that you were, willing to risk and be like, oh, let's see what project management is about, and ended up discovering kind of the skills you've had, what you could bring to the table, and eventually evolved yourself to the role you are today. And I think that's such an important skill that even as a student right now, I'm trying to learn, which is being able to take risks and being open to new opportunities, because you never know where things might click and you might be like, this is what I really want to do. So I think that's incredible. And in this Yeah, and in this journey so far, did you have any obstacles? And if so, how were you able to overcome them? A lot of times we can look at someone's resume and be like, oh, wow, they were successful from day one. But I'm sure you might have had some challenges you've had to overcome. So could you share a little bit about any obstacle you might have had and how you overcame them?
Well, I was fortunate. NASA has been very supportive for children, and I worked part-time for 10 years, and that I was really, really lucky. Not everybody has that ability. I was able financially that I was able to work part-time that and help me balance my home life with my work life. And I had really supportive management at NASA, NASA Glenn Research Center, and they allowed me to work part-time. But quite frankly, they got a bargain in me because I did a full-time job with just 3 days a week working. So there was several of us that young mothers that worked part-time for quite a while, and it did not hurt our careers at all. We continue to progress. So but it does require juggling, and you do have to be organized and make sure you get everything done. But that was, and I have to say that, and even just and finding good quality childcare is that's one of the big hardest things was for me to find was good quality childcare. And my son recently had a baby, and he ended up struggling right still. You have to struggle with. So for me, that was probably my biggest challenge was trying to balance. But I encourage anybody out there, make sure you find an organization that's willing to be flexible with you. I teleworked back when it was still a dial-up connection. I don't even know if you're old enough to remember having to use the phone line to connect in. And so that it was, so that was, there was enough technology to kind of limp along. And now, well, gosh, the flexibility that we all have since the pandemic, that really kicked the flexibility and the IT products and tools up a notch, to give us that flexibility and keep us all connected. So I think that's all just a good thing to help us balance our home life and with our work life. So.
Definitely. And first off, congratulations to your son on the new baby. I'm sure it's a very exciting time for your family. And also, being a mother and having a full-time job is definitely very difficult and something a lot of women go through. I think it's incredible that you're able to balance both and be able to still, figure out when you need to step back from a certain position, when you need to step forward. And I think that's the most important balance to figure out. And so I'm glad that you're able to, evolve from that and also learn from it, grow from it, as well as share that with other women. And so, now that we were able to learn about your journey as well as some of your research and about your journey so far, my last and final question for you is what piece of advice do you have for young students regarding their pursuit of a passion in STEM, aerospace, honestly, any career, a piece of advice you wish you knew when you were younger? So, like, if you could go back in time and give your younger self a piece of advice, what would that be?
I would say to have confidence in yourself and to try new things and don't be afraid. And if someone asks you to do a job, if they offer, make see you because you're lacking enough confidence in yourself while you're still young, you don't know. So what I have learned to trust other people, and then but also trust me, trust myself, that what, if it doesn't sound right to me, it's not because I don't understand, I'm the this we're going to say it harshly, I'm not the stupid one here. The story is not holding together. Like, so if it doesn't make sense to me, then I'm going to keep probing at it and probing at it until I get more data or there's more research done or whatever. And so that came with time. That I used to always assume, well, if it doesn't make sense to me, but this other person says it does, oh, I should believe them. You know what? No, I'm going to trust myself. Trust yourself that you can do it and have confidence and don't be afraid to take risks. That's an important thing, and I think it will help expand your world. And when you have a broader more expanded world. You're going to be able to appreciate different perspectives. You're going to be a better contributor to the project or to your organization, a better leader, if that's the way you want to go. So don't be afraid to try new things and take.
Yeah, I think that was perfectly said of don't be afraid to try new things, to take risks, and most importantly, to believe in yourself and the knowledge you have. I think it's so easy to be like, oh, someone with a better degree or someone who's more experienced than me says this, so that must be the fact, that must be the truth. And then you tend to doubt yourself. I think it's so important, like you were saying, to make sure your voice is heard in all of these rooms, to make sure you believe in your abilities, and to have that confidence to at least ask questions to figure out what's happening. So you make sure that you feel comfortable with the answer. And so just accepting that that's the truth, and always taking those risks. I love to say that you miss 100% of the shots you don't take, which was said by a famous hockey player. It's so true. Like, just take that shot. It might go in, it might not, but at least you tried. And I think that's the most important
Right.
thing. So thank you so much for taking your time today to speak with us. I honestly wish our internet was better because I would have been talking to you about all these really cool biology topics, but this was still a very wonderful interview, and I had a really inspiring time speaking with you today. And so thank you so much for doing this and for responding to my email very quickly to do this interview. It was an honor and a pleasure.
Thank you very much, and I wish you all the best of luck. I'm sure you're going to do great things, and I look forward to hearing your name as you progress through your career, your education, your work career.